Hey guys, William here, and I'm here with my dad, and we're making another Thunderbolt video after like whatever long ago it was when we last posted the video.
It's been a while.
Yep, we're making another one. Like we're making the chopper bigger stuff.
So we got it thrown off because we moved out to Texas. So, but we still have the original Thunderbolt, right?
Yep.
We still we just weren't super happy with it, how deep it was. We wanted to make it more along the lines of a real Thunderbolt. So right now with 3D printing the stator bottom, the motor kind of motor holder to hold the motor in place. And what this is going to do, I'll show you what we did first before we jump to that. We went from a 2-inch motor to a 4-inch motor. So I'm a rotor, about 4 inches. This is a completely new design. It's almost, just looking at it, can't get really good photos of the actual original Thunderbolt chopper. So what we did is I just tried to make it as similar as I could to it. Again, 4 inches, it might be a little too big, but we're gonna see what it sounds like. This chopper I designed this from scrap. I used a little thing that they have on, STL, that they have on Thingiverse, and it allows you to design your own chopper. So this is a 4 to 5 foot chopper. Again, 5 on the top, 4 on the bottom. We're gonna see how this sounds. These are perfectly leveled out and everything. So we did this. We might add somewhere. I have to still. I'm gonna add. I'm gonna add some weights to it. Basically, that's getting the name of that we have for it. But I'm gonna put a bearing too up top. So like this way, it'll hold it more in place, won't vibrate. And this is just an example right now. We just printed this out to make sure everything goes together well, but it's kind of crappy. But what we did is we also designed the ports to, this is a 1002, right? 1002?
No, 1003.
1003. We're gonna put solenoids on it. I have those, like smaller ones, big ones, just to see what works better. We designed these slots about 10 millimeters. I'm sorry, did I do it? 10 to 20 millimeters wide. So it'll compress the sound a little bit more. You can see, and it goes together pretty well. But the whole thing, the whole size of it is, I think it's about a little over 5 inches wide. And what I did is I added 20 millimeters on the sides all the way around. It looks like crap, like I said, but we're gonna redo the whole thing once we make sure everything's proper with this. And it goes in perfect. And it's got very little in between each thing, just so it doesn't hit the wall, so it's a little tighter. And you can see how much room this thing has. See, it goes through, boom, to the top, and bottom. But we have to reprint a lot of things. I'll do the top to make it look like the original Thunderbolt and everything too. But this bottom portion right here that holds the motor in, this is it's gonna go right on top of it, so that motor fits in there. See, I have a little hole in there right now. It's just I have to drill it out for the proper thing. I think it's 2.3 millimeters for the shaft of the motor, but it'll allow us to put this right on top. And we're gonna get a couple screws in here, like 7 or 8 screws, probably 8 screws around, and then there'll be another base that's gonna slide. It's gonna be just like this upside down, and it'll it'll be able to just slide right up against it like this, like the original Thunderbolt does. I don't know if any of you's ever seen it. I think that uses an armature motor, which is the 2-piece motor, the original Thunderbolt. I could probably get it. I've been looking to see if we're gonna go to that route, but as of right now, I'm gonna stick with like a 12-volt RC motor. See how that works. But it'll fit perfectly on this. It'll be the same edges on the other side, and we'll be able to bolt a few of them through. It's gonna, again, the bottom half that we'll print right now looks just like this upside down, except it has a motor holder in it, and it'll allow us to slide right up on it. So we'll slide up on it, and it'll all be that bottom portion of the chopper housing that'll slide up. So that'll have like 2 bolts that'll hold it together in place. But this will be pretty much just the way this is right now. It'll be like chopper housing and motor housing and a stator, whatever you want to call it. But it's still doing a lot of work. Again, I wanted to see how wide we're making these. I think this is my calipers right now broken, but the new calipers. Where I make this? Oh, inside. So the inside of that, yeah, I did it at 10 millimeters. So these are 10 millimeters each. On the outside, that'll allow us to get that new horn. We gotta see what size horn we're gonna put on this. I think we're gonna do one. We have a what is this? 400 by 400 by 500 tall millimeters. So it'll allow us to go up to about 450 millimeters for the horn. We could either do that, or we could do it, close to the 800. And we could just do it in two separate pieces and just mold it together. We have like 3D printing pens and all that kind of stuff to like work around it. But I did kind of sand this down because I had to replace the nozzle that we had because it just did not print well. You can see like there's a little bit of I had a little bit of shifting, so I have to. I worked on it. I played with the printer the best I could. I have a glass bed that's upside down, so it has a little bit more hold to it. But again, this is an Ender 3 with an extension kit on it. It makes it 400 by 400 by 500. And there it goes, it just screwed up. So, but still working on it. It's just actually that might still feel right. I just think we done right. But we're still getting back into it. Again, we're gonna use these two that we have right now. I have a bigger one. Again, these are 12 volts DC. And allow us to come out like we did last time. What do you call that thing again? Yeah, the solenoid holder. We're gonna redesign that as well and allow it. I was thinking of doing some kind of slide down, so it could slide down into it, and you'll have the little wings on each one of them. That's a lot of measurement. This is a pain in the ass to measure. It's a lot of work, and it doesn't seem like it. This is a little guy. I mean, this still does well. This is another, I think this is 12, yeah, this is a 12 volt DC too, but it uses less amperage to get this. And again, the amperage is a nightmare to do. They're just trying to make sure everything's right. We have, we have a lot of different stuff to play around with. Again, we're using inland filament matte PLA, make it the closest color to it. If we can get this Thunderbolt down and everything perfect, it'll allow us to sand this down a little bit and put on a nice gloss, well, like semi-gloss yellow, like the original Thunderbolt. I think the sun yellow is called or something like that. So we'll use that. Maybe we'll make it look antique-y, putting some rust on it, and, Rust-Oleum, sell some cool spray paint. But we're gonna do that. A couple clear coats, but we want to get this thing sounding deep and sounding nice. If you guys have any suggestions at all, please below, let me know. I don't know if 4 inches is too big or not. This is a different territory. Do me a favor, go ahead and grab the Thunderbolt so we can show them just the housing. Well, I'm gonna have to redo a lot of stuff. I don't know why that messed up. Well, I've been using glue to try to hold it down. Some of this glue. Stick for some reason, we go through a lot of this, but this is the only thing to hold this on a glass bed like this, especially this size. The glass, yeah, it does well, but it's still, you want to make sure it sticks on there. I didn't use any before this, so that's probably why it screwed all up. Here's for you, the portions of what we have left. It's a mess. But everything's taken apart and sad to see. But what we did is we used a new, I can't think. This, allows the wires to spin, so they stay taut on the bottom. They don't move. And the wires up top, they spin. So it's a two-piece. I forget what they call it now. Some kind of, it spins. It's a coil spinny thing. I don't. There's a name for it, but I forget the name of it now. This is our little controller that we were using. I forget where I got this from. Amazon or something like that. but this allows it, it's all wired up. So this allows you to, when it's on, you could set your points so that the, I don't know if you guys want to take a look at that. It allows the wings to do its thing, the solenoids to spark each other. We have an old motor in here. This is the original OG motor that we had to spin the whole stator around the chopper housing. Little tiny guy. Look, Amazon makes them look so big, but they're really not that big. But inside this, what we did, this is pretty big and cool. This is a lot of work. I used this thing. It was a gear ratio. It brings it down to, what is it? 4 rotations a minute or something like that.
4 RPM.
4 RPM, yeah. And we used a little old actual, one of the belts from the Enda. And we just kind of glued it together. And it allows it to do that 4 rotations per minute. And I designed a little gear that's in there, a gear, so it spins perfectly. I still have a little bit of working to do with that because as of right now, and that works well, like I said, but it's got its own little motor in there too. I don't know if you can see it on the back, the wiring's coming out of it, but it's a little tiny motor, just like that motor I just showed you there. It's very similar. It's got good torque, decent amount of torque, but we have to see how it goes with that. But basically, like I said, hold this up real quick. Okay. Like I said before, with this, this is going to be a bigger version of this. That housing, I mean, you know, the motor housing is going to go on the bottom of this, and there's going to be another one that's like this. It's going to slide over the whole entire thing. So this whole piece will just slide right into that. Doing a lot of noise. But I'm going to try to get this up. And you can see I use different kind of PLAs. I like this one right now. It's the PLA. The inside of the box, you want to turn it around so we can just show them. There's a lot of wiring in here. This is going to be a pain in the ass to fix some of it. You see I did the switches. I had control the chopper, the switches. We're going to go with touch button switches like the original Thunderbolt. I got to find something like that. Again, any suggestions that you guys have for switches, let me know on the bottom, but they have to be compatible. You know, regular 12 volt switches. I like these are not bad, but we want to make it more like you could just touch button.
Yeah, like an arrow timer.
Yeah, arrow timer, like that. This allows the speed control, 12 volt speed control, and a little switch that does nothing right now, but I have to incorporate it enough to be able to press the button to start spinning it. You can see we actually put, look at that, we put the CD in it, but pretty cool. I mean, this is a lot of work. We're gonna redo this too. But I like the way this came out like this, and I designed it like this. So little pieces like that. So this way, when we do it, we can make it look vintagey, like it's been outside for a while. Yeah, tell them. It's gonna be awesome. We're gonna get it to work this time.
Yeah, we're gonna be able to fix it up.
We're gonna put it outside. I'm gonna also get a piece of PVC. I think we're gonna do a. We're gonna try to make it like 3 or 4 feet tall. Yeah, 3 or 4 feet. The blower motor, we're working on that. We're gonna get this new blower motor that they have. It's a higher pressure blower motor. It's gonna be like more commercial. I think it's like $50 or something like that. But once we're done with these and we get these perfected, look at that. Even the hinges, by the way.
Yeah, I want to add.
There was a crappy print that came out. But even once we get this done, we're gonna try to sell them. So
yep.
You know, I'll be one to sell them. I'm gonna keep you guys up, and also probably if you guys have a 3D printer, once we're complete, I can't promise you anything, but we might release the STL. So if you guys put your own printer, but you're gonna need a big ass printer like this. And this again, 400 by 400 by 500. This is just a regular Ender 3. I do have a lot of stuff. I have a different motherboard than this. The motherboard is, I forget who even made it. It's a silent mode. That's why it doesn't make a lot of sound that you hear. Micro Center. It's quieter. It also, the programming for this is a nightmare too. I mean, it's got its own custom firmware, so it allows it to, you know, to compensate for that 400 by 400 by 500. And everything else is done. This was done. That pulley was done on it. We have an aftermarket pulley on this bolt. Well, so this thing's been sitting for a while. I mean, I still print stuff, but we don't go crazy right now. But again, if you guys want to look at this, that is 4 inches, and then tall, or about 2 1/4 on the height. And this guy right here, about 2 1/2. We add a little bit more so you give it a little bit more leeway inside. Again, we're going to redesign this. We're going to put the bearing up here. We have to figure out a way to put either a bearing up here, and the bearing, actually the bearing will be sitting in this, and this will be nudged up a little bit so that it can fit right into the bearing. Or I'm going to do like a little tip on this, with a little nipple on top of this, that'll fit right into the bearing up top, and it'll spin a little bit more freely and quieter. That's what we did in the other one. It's a much smaller bearing. I have other skateboard bearings and other ones, so keep up to date and tell them. See you soon.
See you soon.
Oh yeah, too. I want you guys to check out. Tell them about that.
About the
Gunther.
Now the Gunther Thunderbolt, we're gonna post that video. We want the Gunther to look at the Thunderbolt for a bit.
Took some cool pictures. We got real close ups of it. It's old, really old.
I wonder if they'll restore it.
All right, we'll check it. We'll put it in the video. You can look at it. Tell them. See ya.